Welcome to this talk about data acquisition automation for NiFi in a hybrid cloud environment. We're going to talk about Liberty Global's journey towards becoming a data-driven organization with DataOps. Who we are? So Liberty Global is a multinational cable company present in Europe in 10 different countries as per the figures of end of 2018. This is subject to change with different acquisitions going on, but in sum, we have around 45 million subscribers for TV, broadband, telephony services. And we have significant investments in media companies such as Lionsgate or Formula Electric Racing. So our brands, as you can see, are Virgin Media, most famous ones, Vodafone Ziggo, Unity Media in Germany, Telnet in Belgium, and UPC. So the speakers, myself, Arda, I lead the data solutions team in Liberty Global, and Ivan Georgiev, my co-presenter, working as a big data and cloud solution architect at Devo team. So we'll start with 3 quotes to describe the problematic we're facing. The first one comes from our head of data analytics. Is about the agility to deliver different data sets in a big data platform. And the main concern is about what we call time to data. The second point is from our data protection officer, who sees GDPR as a major force to make conscious decisions on data acquisition process, so meaning the collection, the usage, and the retention of data. And the last one, related to the previous one, is about how we ensure that protection. So what we can call as security by design, we ensure that each data set that goes into the data platform is secured by design, either using anonymization, tokenization, or encryption techniques on field level. A short definition of what we call here data acquisition is the process of gathering, filtering, and cleaning data before it lands into the data lake. Another short definition about DataOps. So Wikipedia definition. If we have to retain something, it's agile combined with DevOps, combined with lean manufacturing. Quick note on our key partners. In terms of technology, Cloudera, Microsoft, Atlassian, and Secupy. And for the integration part, we work with Devo team. So quick look on our data architecture, our reference architecture. So as most data architecture diagrams, data flows from left to right. Sources on the left side, typical sources. Also some cloud sources there, which are new for us. There's maybe something that you have not seen before in terms of wording is the data privacy gateway. So we use that closed environment, let's say secured environment, to acquire data into various places. And on the right side, we have the data lake, which combines basically the Azure cloud ecosystem with our on-premise ecosystem, which runs mainly on HTTP. The processing in the cloud, so the storage in the cloud happens on native storages for Azure, which are Azure Data Lake Store and Azure Event Hub for streams. And the processing happens on HDI, on HT insights. We use certain components from HTTP for lineage, for instance, in the cloud as well. Atlas, to be specific. And then the last layer is to provide access to our end users. So mainly using, for data science, we use the same Spark ML as the default processing engine. And yeah, we have dashboarding solutions such as Power BI, etc. in the cloud. And on-premise, we use dashboarding through ClickView. And again, the processing happens in HTTP if need be. The bottom layer for the governance and DevOps tooling, we use Jira to capture the demand, Bitbucket for our Git repository, and these various tools for managing provisioning environments using CI/CD, as well as monitoring the environment. A quick look at our infrastructure locations. So we have 4 data privacy gateways located in various countries, and our data lake on-premise is located in the Netherlands, as well as we use the Azure cloud services that are located in West Europe, in this case, Netherlands. So a quick zoom into our data privacy gateway. So we have 3 use cases. So for the, let's say, non-sensitive data use cases, that need to go, so that when the workload needs to load the data into the cloud, we use the default solution provided by Microsoft, in this case, Azure Integration Runtime, combined with Azure Data Factory. When we want to replicate data with CDC from a traditional database source, we use Attunity Replicate. So we can load the data either in the cloud data lake or in on-premise. And for all other use cases, we use NiFi. So mainly, we use NiFi to manage sensitive data in this case. So we have built a custom hashing API that allows us to obfuscate or de-identify sensitive fields, either on structured data or semi-structured, such as XML and JSON files. And then we're able to do various transformations and then load the data into the data lake. The thing to retain here is that we don't do format level transformations to keep the data as is in the source. We can combine several sets together, but we try to not touch the data at all at this stage. So before we zoom in into NiFi, quick summary. We use the data privacy gateway to land data into the data lake, either on the cloud or on-premise. And we also manage the sensitive data on the fly before landing the data into the data lake to ensure that that data lake is fully GDPR compliant. So with that, I will pass the ball to Ivan, who will tell us about our journey.
So our NiFi journey, it began somewhere about May 2018 with many iterations. We came through the whole journey. The first iteration, the first release was about providing data for privacy analysis, for privacy evaluation, coming with all the sources implementation. Then we had to solve scalability issues in August 2018. So every iteration we've gone through, we had to do a lot of re-implementation, a lot of manual work, a lot of repeating testing, regression testing. In September 2018, we did another release for resource usage optimization. Also, in October 2018, we had to provide GDPR compliant data, so we came with the first solution for GDPR compliant framework using custom built NiFi processors. In November 2018, we had to rework everything again to write to multiple targets from all the data pipelines. And in December 2018, we went in production. So this was our first real production movement. To move to production, we had to enable using NiFi registry as a version control system for the NiFi flows. And after we went in production, the security department came in and said nobody can access production. So how we are going to deploy, how we are going to monitor what's happening. So we had to come with a solution. So in February, we came with a custom-built NiFi CI/CD pipeline, which is built around popular and well-known DevOps tools like Jenkins, NiFi registry, Python, Bitbucket, all the family tools. So after we came with the CI/CD, we looked back into the backlog, what comes next, what should we do next, and what we discovered actually that our backlog is huge. A lot of change requirements came during our last release, a lot of new application requests, and we cannot handle everything at the same time. It looked like 1 year later, our backlog is much bigger than it was 1 year ago. So we came with questions. What can we do to make these things possible, to do the changes, everything to happen very rapidly? And yeah, we came with something that we call NiFi Builder. NiFi Builder, this is a automated tool that based on a flow descriptor, it creates NiFi flows. We'll have a short demo on the NiFi Builder in a few minutes. So NiFi Builder supports not just NiFi, it also supports other platforms as Azure Data Factory. We haven't done other implementations, but it can also build against other platforms. And it enables rapid development, rapid changes. Also, it eliminates a lot of manual work. In this way, it eliminates a lot of waste. So, NiFi demo, I'll show you a video. And so, yeah, for this demo, I implemented two scenarios. The first scenario was simulating a staging server. I used the public New York City taxi dataset. So the staging server collects logs, zips them, packages, stores into persistent storage, and then NiFi picks them up. So this is what the descriptor looks like. There's the name of the flow that is used also in NiFi. Here are some sensitive properties of the pipeline, and here are the steps of the pipeline. So initial acquisition, tagging flow files for flexibility and standardization, unzip and storage to a storage container, in this case in Azure. This is where our flow will appear in NiFi. And this is our storage container. It's empty at the moment. Running the NiFi builder, it's a Python application. As you see, with a blink of an eye, everything is ready. We refresh, and we can see our flow in NiFi. So the steps: acquisition, tagging flow files, unzipping, storing, everything is there. And if we change the implementation of these steps in the templates that are used to build the flow, you just rerun everything and the flow is rebuilt again. When we start the flow, we can see data flowing through and going to the storage container in the data lake. Yeah, here's the root location. Then going inside, we can see our files, they arrived. In the second scenario, what actually happened with our client is we had to replace the staging server with Azure Event Hubs. And also there's another requirement. Privacy says you need to anonymize the vendor ID, the first column, and also for performance, for efficiency, we need to merge the small CSV files into bigger files. So I took the original descriptor, did modifications. So here I added some more sensitive information for the Azure Event Hub. Then I replaced the acquisition step with acquisition from Event Hub instead of file-based acquisition. I changed the name of the source system so that the data will be written in different locations so we can see differently the data. Here is the anonymization step is added, and merging the small files into bigger files also. And the storage step is the same. So now we can run the builder, but before this, we need to stop the NiFi flow because the builder will replace the flow. So first we stop it, and then we restart the builder with the new descriptor. And again, you can see with a blink of an eye, everything happens quickly. It's refreshed. Here it's updated. When we look inside, we can see the new flow with the acquisition step, tagging flow files. Here's the new step, anonymization, merging of the small files, and the storage. So if we zoom in a little bit and we start the flow, zooming again a little bit, yes, and we can see data flowing through the pipeline. So all the data, anonymized files merged into bigger files, and we can go and check into Azure storage container to see things happening. So checking the Azure storage container, it will be in a different root location because I changed the source system name. So opening the yellow, we can see the files here, and we have something like 100 times bigger files than they were before. So this is the demo for the builder. Ardo will continue. Yeah.
Thanks. Thank you. Cool, right? We thought of, okay, we have now an automation step for building NiFi flows. How can we infuse that into our business processes? The main challenge we have, so this is before DataOps, one of the main challenges is around gathering the business requirements and ensuring that all the parties agree on how to proceed forward. Oops, I pressed the wrong button. Yeah. So let's take the business team. They come into the picture and they log a request in Jira, a ticket, and basically they ping the developer. And the discussion starts back and forth, and until the Jira ticket is updated with the right information, there are quite some exchanges. And once everybody agrees, then comes into the next team. So this next team can be the network team, IT operations, or any other team in the business process. And in this case, we'll take the privacy team. So the privacy team is going to check basically that the sensitivity is of the information that is going to be ingested into the data lake is appropriately handled. And again, they update the Jira ticket, for instance. Lot of back and forth discussion now between this new triangle and Jira. And once all the parties agree, there you go, the developer can start the work. So we go into Bitbucket, we deploy, let's say, the descriptor mentioned by Ivan in the previous demo. This goes into the DevOps tooling. The code has been deployed in NiFi. Then the several CI/CD, the similar CI/CD pipeline happens into the data lake and access layer. The code is deployed there, and at the end, the business can access the data through, either SQL, Spark SQL, or any other interface. But if they're not happy with the result, then the whole process has to reiterate, right? And you have the privacy team involved again, all the different parties might be involved again. And if they went through the wrong data source because they missed a specific field there, then yeah, everything has to restart. So how could we optimize that? That was our question. So to reiterate, the challenges were the following. It's difficult to capture requirements in a consistent and standardized manner due to the involvement of various teams. All the approval flows and different processes involved in this process actually is not always done in one environment. We are using Jira, but there are certain teams that want to use SharePoint or just an Excel template. And even if we were to use one platform, it's really time consuming to fill in all these forms. And we have to push people so they do it in the right way. Because if they make a mistake, again, the whole process has to reiterate. And the last point is that most business teams in our ecosystem do not know how to figure out which data set they want. They don't know how to connect to the source system or don't know how to read a technical lineage diagram, for instance. So we need to kind of help them understand this technical information. So we decided to do a POC and see if how this works, to combine all the governance and DevOps tools and integrate that into the business process with another layer. So the proposed solution process flow is as such. We put Azure Logic Apps in the middle to integrate all the different steps. We have built a data platform portal to capture the demand in plain text. We have used some Azure Cognitive Services to interact with the end user so that he or she can specify the requirements in an interactive way. Then the Logic Apps goes into Jira and logs the information there in a standardized format for each data set, basically. And then the different approvals flows are generated automatically. In this case, system owners, data owners, privacy, etc. And then the data set acquisition is tracked from requirement till the production deployment in this specific ticket. Next step, we go to the DevOps tooling. We generate the code. In this example, it will be using NiFi Builder. We store it. If needed, we also build artifacts. We can also provision the cloud environments automatically, if need be, or if it's an existing environment, we just use it. And we manage the deployment through the DevOps tooling. Then the logical next step is to deploy the code in NiFi, or to build it in NiFi first, and then deploy it, promote it to higher environments after the approval is received, of course. And the same for the HTTP HDI layer. And in this case, this is the Spark data curation into the data lake, which is consisting in converting the format to Avro and building a Hive table on top, but that's details, yeah. So, and the end result is that the end user can query the data at scale in the data lake. So let's see how this works. So we choose a pixel art based theme for our portal. Basically, this will be the single place where we capture all business requirements and the trigger point for all requirements coming from the business. Obviously, we can also go back to the Jira board and put comments there, but we'll try to enforce people to come into the portal and input their requirements here. So I will just quickly walk through the different steps. So after the request is generated in the portal, we go into Logic Apps, we gather dataset details from the business glossary. Here it's a mock-up interface. It's just a set of variables, but you can interface that with your data governance tool. Then we go into Jira, we create the ticket with the relevant information captured from the portal. Then we'll be looking into Jira. So this is the view from the technical product owner view, the person who will do the impact assessment. Then we have chosen one extra business team, in this case the privacy team, which will have a privacy approval board where they will need to basically confirm or disagree with the specified impact on privacy. Then the Jira will trigger, again, Logic Apps, which in turn will trigger NiFi Builder with the relevant information that is stored in Jira. The next step is to go into the NiFi flow. So this is the process from the previous demo. And the next will appear here as well, the new one. And the storage where in the data lake where the data should be basically created with the relevant rules, which is now empty. So we'll go into the portal. Again, there will be more services. For now, we have data acquisition from the getting data into the data lake, or getting out in this case. So the interface is a chatbot interface, as mentioned. So we're able to interact with that data acquisition chatbot. We specify the source system from which we want to acquire data from. Because it's a pan-European system, we have to specify the country, in this case Switzerland. The dataset name, the type of data in this case, refers to the dataset name from the business glossary. And the frequency of refresh, in this case hourly. We kept it simple for the demo purpose, but this interaction can also go on quite a long time, of course, depending on your requirements. So now we're going to check the logs, see if Logic Apps picked that up, picked the request. So it succeeded. Yep. And next step is we go into Jira. and we see that the ticket was created with all the relevant details in a structured manner. We can also eventually fill in forms in Jira. We can attach this request as an attachment into the ticket. And there's also the business glossary step that enriched that initial request with the dataset description. Obviously, we can put there field types, etc., but for the demo purpose. So the impact assessment starts, and automatically the privacy approval ticket is created. Now I will go to the other view from the privacy approver's point of view. But before that, we're going to put there a manual step on purpose as part of the impact assessment process. This can be any other step. In this scenario, the product owner will define the fields to de-identify manually. And we recommend to hash the MAC address with SHA-256. So now we go to the privacy approver point of view. So the subtask automatically appears on the board. And all that the privacy approver has to do is to look at the dataset, structure, and either approve or reject. Obviously, this is a simple scenario. We could also attach sample data. There are various ways to tackle this, but for the demo purpose, we kept it quite simple. So next step is that we're going to go into logic apps. So the status passed from impact assessment to implementation, and this triggered the logic apps to call NiFi builder. Again, we look at the logs, and it was triggered successfully. And the next step is that we go in NiFi to see if our follow appeared, and it did. By default, it's not running in this case. We could have also triggered the run, but yeah. We're going to show that the storage is still empty. And normally, once we trigger the flow, the data will appear in the target storage. So this is the initial file, how it looks like, with the MAC address in the clear, let's say readable. It's a mock-up one. And normally, once we open the file, we'll just skip the conversion. Yeah. We have the hashed MAC address in the data lake. Right? So we showed that we can take the data from the source system, hash the data, and land it into the data lake. Right. So what are our next steps? We want to fully integrate with our business glossary. Here we use the mock-up dataset, but what would be really nice is that we could have the chatbot understand all the data that is available in the company and display that to the end users, as well for the privacy management part. And also we want to integrate with our application landscape management systems so that all the source data can automatically be, or source systems can automatically be listed and the integration done afterwards. We want to automate the connectivity checks and requests. So for instance, if this is a new source system, we don't connect to it yet. We want to be able to trigger that request automatically towards the network operations team. So this can be also seamless. Obviously, monitoring and support is one of the priorities, and then we want to start the closed beta stage. And then based on the experience from the closed beta, we want to improve our processes and ensure that this takes even less time than what we expect it to take now. And next steps for improvement for us is data integration automation, data quality automation, and dashboarding automation. So, yeah, some funny part for the end. So automation is definitely something that could be leveraged to ease some of your pains, but it's not about only technical challenges that you have to face. It's also about other types of challenges, the perception, for instance, and the habit of people. And as per the second one is, as Ivan mentioned, we were faced with a huge backlog, and that pushed us to stop and look back and see if we can do things in a different way. If we didn't mark that pause, then maybe we would not have thought of implementing automation, and we would just continue and reiterate it in trying to do things the way we were doing it before. And that concludes the presentation. So, any questions? Yes, please.
Thank you. I'm more interested on the CI/CD part for NiFi.
Sure.
So, is it open source? Can we use it? And how did you tackle the downtime problem when you're trying to deploy something, but there are some flow files already in the flow, and you cannot deploy right away? How do you tackle this?
I think I should answer
Sure.
this question. Yeah, this was one of the challenges when I was writing initially the stories, how this should work. So in the NiFi CI/CD pipeline, it stops all the processors in a wave. So it starts from the end, stopping processors until all the buffers are emptied. If it fails to empty the buffers in a predefined timeout, then it stops, triggers an error, and somebody needs to look at it. But this was the attempt to make things work automatically, the best way that we can do this. Yeah, this is how we implemented it. This way also, we stopped just the pipeline that is deployed, not the whole NiFi flow, just the small part that is subject to the update. So, yeah, this is to be decided. Probably yes. For the NiFi builder, it will be open source. It's actually already in GitHub, but I haven't published the repository. For the NiFi CI/CD, this is something to be decided. Maybe yes. I think yes. Yeah.
It's to be decided. Let's put
Because NiFi CI/CD is not that easy to integrate. It's not a self-containing part. NiFi builder is self-containing. NiFi CI/CD, it needs to be integrated with Jenkins, with Bitbucket, with many other things. So it requires also a lot of documentation. I don't like this open source project where you go, there's just a simple page, welcome, and what should I do? Yeah. Okay?
Yeah. Any other questions? Yes?
So the question is, because you have that Jira workflow and other stuff that somebody need to provide some details, why you didn't allow people to just create a workflow in NiFi? Maybe it's not possible, to be honest, I'm not familiar with the tool, but it seems that your workflow is always pretty the same, yeah? So you just need to provide some details, gather the requirements, and then you have that builder to build the workflow. So why not allow to just access NiFi and create the workflow
I
there?
think, yeah, I can answer it. So we have different levels of knowledge in the company regarding dataset acquisition. NiFi is a very new tool, so we are really a closed, let's say, group for now who know how to use it. And I don't believe you can give access, like restricted access to the specific usage of templates and specification of sources. So for instance, you cannot prevent someone from going into a dataset in NiFi and not hashing the sensitive information, right? So this workflow actually ensures that we follow the regulations and the policies that we need to adhere to. That's the main reason. And all this is logged in Jira.
Also, there are some other reasons, like, as I mentioned, there was a lot of evolution in the patterns that we used. So initially, we used some patterns like get, put, then it evolved into list, fetch, put, then we had to put anonymization. So all these changes, somebody needs to go into manually. And this is not the end user who should do this. What we are trying to achieve also is to limit the technical requirements to get your data. So you go, you just type what you need to have, and you start getting your data into the data lake, and you can query it in a matter of hours. Actually, the most time-consuming part is to get through the approvals flow through the company. Everything else happens more or less automatically, and we have a huge diversity of workflows. It's not just what I showed. We have a lot of things happening. We even have re-anonymization, a lot of things. Yeah. Yeah. NiFi Builder, it will be open source. It's a Python. It is in GitHub, but I'll publish the repository. Yes, and yeah, it's also another interesting thing that we didn't mention. NiFi Builder is also a web app, so we can run it as a web app. I run it as a command line for the demo, but for the others demo, it was a REST API.
Okay, thanks. Great solution. Thank you for the presentation. I saw at the end the user or the requester is informed by email. Is that correct?
Yeah.
Yeah.
Correct.
Have you also thought on like put it into a data catalog or something?
Yes. So this was the business glossary part, I think.
You use Azure Data Catalog for that, or?
Right now, it's under assessment which business glossary we're going to switch to. But yeah, there are multiple candidates.
Okay, and the security theme, have you addressed this too in this solution? Who can access what data?
So yeah, here we have, we didn't talk about the access layer, but basically access is part of the approval chain. So depending on your group, the requesters group, they get an access subtask that goes to the data governance team, and the data governance team already has a catalog with all the accesses, basically.
So we have a role-based access control on dataset level. So every dataset has defined roles, and you get access based on your role on the dataset, acquiring permission from security and from the data owner.
Congratulations, guys. I saw that you are running on Azure and you're using Jira. So as like a block in your solution, is it easy to replace Azure for a different provider? And if your management like tomorrow tells you, guys, we don't have like enough money to run on Jira, is it easy to replace Jira for Trello, for example? Is it as easy as like creating a new template? And if so, can like 2 or more templates communicate between each other?
The last bit, the template part.
Yeah, if tomorrow you want to run on a different provider and instead of using Jira, use a different provider, how will you handle it? And will it be easy as like creating a new template with a new flow? And if so, can templates communicate between themselves?
Good question. Right now we have no plans for supporting other providers, but as you have seen, we have a choice of using logic apps as a integration layer between the different parties. So this is native to Azure. If we were to use something else, then yeah, we would need to use another solution. As per, yeah, if Trello, I'm not sure it can work with the REST API, but if it can, then yeah, we could integrate with Trello quite easily. But yeah, the requirement is that we have to have a REST API integration with the.
So the coupling with Azure is only on the logic apps. Initially, the demo that I recorded was on my laptop, but then Arda came and said, let's have everything on the cloud so people see that we work not only on laptops, we work also on the cloud. So I had to do this over the weekend on Sunday, having everything, and yeah, it's much easier also. But the platform is really not important. The underlying provider is not important.
And most companies have their own, process management software. So, like MuleSoft or something like that can be used as well for the integration layers. Also, as Arda mentioned, the platform is hybrid. So we have parts on premises, parts on cloud. So we demoed the cloud part, but it also works on the on-prem part. So it's already showing that it's not coupled with the platform underlying. Yeah, and we have a lot of other features in the backlog for the builder, for the NiFi CI/CD, for the DataOps, the data factory.
So yeah, a lot of new cool stuff is coming to make things much easier and simpler.
There's a question.
Yes. Well, thank you for the presentation. In terms of performance, is NiFi able to handle, like, say, 200 data flows running concurrently, or are you?
I think we're quite happy. In the beginning, it was a bit more of a challenge. We had to implement, like in the journey Ivan showed. There were several steps to get there. But yeah, I think today we're pretty much okay.
Yeah, we were doing not just ingestion, we also do some data management. We have just three NiFi nodes, and we managed to do something like 14, 16 terabytes per day, which is pretty much cool. We have almost all kind of data sources that you can think of, and it's worked pretty much very well. Initially, as Arda said, we had a lot of issues. We had to learn a lot of lessons. We had to do a lot of iterative discovery, exploration. This is why we came also with this NiFi builder, because it allows us to change the approaches to validate different prototypes. Also, NiFi changed. NiFi, they did some upgrades, processors changed, and NiFi also went a very long way in 1 year. In 1 year, because I started closely working with it in May. I'm the NiFi guy. They called me NiFi guy. So I'm not just the architect, also I'm the NiFi guy and the BSA guy. So yeah.
And in terms of the organization, the flows in the user interface, because as far as I know, you cannot have several workspaces in NiFi. So how you, if you end up having like 200 data flows, how you organize I think there's something called processors groups, right?
Yeah.
So that is the only way to organize the data flows?
This was one of the cool things that happened with NiFi 1.8. Before, we had to use remote process groups, input port on the root level, and you cannot structure well. Yeah, initial design that I did was really having namespaces, embedded namespaces, but it didn't work because of this remote process group. But when it came, then we had, we are going to rework everything because it gives us a lot of flexibility in the namespace. So we use also nested remote process groups. The NiFi builder, you can specify, I want my flow to go into this process group, so you can nest them. You can have really nested structures, hierarchical, and I like what we achieved at the end.
Thank you very much.
The group might be interested to know, I'm on the NiFi dev team. I don't only carry a microphone. We did a scale test the other day, NiFi and Kubernetes, just for fun. 12 petabytes a day, doing record passing on log files.
Good.
It was about 500 node cluster.
Yeah.
Okay.
Probably not something you use in production, but it was cool.
Good to know we can scale.
Oh, yeah.
Cool.
Is it scaling automatically what you did, or it is manually scaled?
The operator model in the Kubernetes setup is not auto-scaling yet. It's manual scaling, but the stats are there. We just haven't built it yet.
Okay. Good. Great.
All right. Thank you very much. Oh,
Thanks.
Thank you.